Okay, so in this video I'm going to go over the Chapter 1 review. The first question wants me to sketch the graph that represents a reflection over the x-axis, a horizontal translation 3 units to the right, and then a vertical translation 2 units up from the graph of y equals the absolute value of x. Remember, this is a function that looks like this. This is my y equals the absolute value of x. So I'm going to be changing this function. I am going to go 3 units to the right, and then 2 units up, so right here, and a reflection over the x-axis means that instead of going up like a V, it's going to go down like a mountain. So this is my new graph. I need to give my new domain. So my domain here is going left forever and right forever. So I'm going to write my domain as -infinity to +infinity. My range is my possible y values. It goes down forever, but the highest point it goes up to is 2. So my lowest point is -infinity. My highest point is 2. And it can include that 2, so I want to actually make sure I have a square bracket there. C is looking for where it's increasing. Remember, this is code word for positive slope. So I have a positive slope from -infinity all the way to, I always use my x values here. So I am going from -infinity, because I'm going from the left side, and I'm stopping at my x value of 3. These ones only get parentheses. Then my decreasing is where my slope starts to go down. This starts at 3, and it goes on forever to +infinity. Number 2 is asking what transformations changes the graph of f of x to g of x. So I'm looking for what each of these numbers are going to be changing. So this number 3 on the inside is going to move it left 3, because it always goes opposite the sign inside the parentheses. Then I have this -4. That means it's going down 4. Numbers on the end go up and down, same as their sign. Numbers on the inside are left and right opposite their sign. And then this 2 out front, because it's out front, it is vertical. And then because it's a whole number, it's a stretch of 2. Then I want to go ahead and graph these. I am going to graph on my calculator. Oops. X squared, and then this one is 2 parentheses x plus 3 squared minus 4. I'm going to wait for these to graph. Okay, so I can also, if I couldn't tell by looking at the equation, I could also graph to look at the differences. This vertex is moved over 3 to the left, down 4. And then it's skinnier, so that gives it a vertical stretch. I do want to graph this on my paper, so if I go second table, it will give me the table of values. I'm going to go a little bit negative because I saw that my red one was on the left side of the graph. I'm going to graph a few points. For my parent function, it's 0, 0, 1, 1, 2, 4, and then -1, 1, -2, 4. So this is my f of x. Then for this one, I have -3, -4. That's moving left 3, down 4. And then on the right side, I have -2, -2, -1, +4. On the right side, I have -4, -2, and then -5, 4. So then I just want to connect those, and this is my g of x. Okay. Number 3 wants me to graph this piecewise function, so I'm going to graph this part in blue. I am going to plug this into a table of values, and I'm going to plug in my 2 end values. I have -5 and 0. So -5 plus 3 gives me -2. And then 0 plus 3 gives me 3. I'm going to go ahead and graph this on my paper. -5, -2. This one gets a closed circle because there's a line underneath. 0, 3 gets an open circle because there's no line underneath. It's linear. That means a straight line because there is no exponent in here. So I'm going to connect these 2 points. Okay. Then my next piece I am going to do in red. It's 3, so this is a straight across line between 0 and 4. Both of these should have open circles because there is no line under either inequality. Then my final piece I'm going to do in green. So I'm going to plug into a table of values again here. I'm plugging in 4 and 8. Those are my 2 end values on the inequality. -4 plus 7 gets me 3. -8 plus 7 gets me -1. So I want to go ahead and graph this. 4, 3 is going to get an open circle because there's no line under here. 8, -1 is going to get a closed circle because that has a line. And then I want to connect the dots. Number 4 says I have 4 cups of sugar. It takes 1 cup of sugar to make 30 brownies. The function b of s equals 30s represents the number of brownies that can be made with s cups of sugar. What is the domain of the function that represents the number of brownies that can be made with s cups? So the key thing I care about is how many brownies I can make. I can always choose not to make any brownies. So I can have square bracket 0. I need to figure out my maximum amount of brownies I can make, so I'm going to do 30 times 4 because I only have 4 cups of sugar. That gives me 120. So that is the most amount of brownies I can choose to make. Okay, this one wants me to graph the equation and find the solution by graphing. For this one, I want to split it up into 2 graphs. I'm going to have -2, absolute value of x minus 1 plus 3. And then I'm going to have y equals 2x minus 11. So this first one, it's going right 1, up 3. And then it has a vertical stretch of 2. So this is what this one looks like. And then I'm going to graph the second one. I'm going to go ahead and graph that in red. -11 is right here. And my slope is 2x, so I go up to over 1. Oh, I graphed that blue one wrong. It was a -2x. So it should have been going down. Let me go grab my whiteout really quick. It's on the other side of the room. I am going to white out this because I graphed that wrong. And I did it in pen. So the negative means it goes downwards. Okay. So this intersection, I am going to check it on the calculator because I don't trust that I graphed it by hand with perfectly straight lines. Oops. So I want to go to y equals, I want to clear out my 2 functions that I have here, and I'm going to type these 2 in. So I have -2, I'm going to go math, arrow over to num, press enter, then I type my x minus 1, then I have plus 3. Down below I have 2x minus 11, I go graph it, and then I just need to wait for these to graph. Wow. Okay, so notice this blue line and this red line are parallel. Those 2 are never going to cross, but they are crossing at this point right here. So I go second, trace. Then I want to look for where they're crossing, which is an intersection. I want to get close to that intersection on the blue line. I press enter. Now I'm on my red one. I press enter. It likes to guess for fun. I press enter one more time. And this gives me x equals 4, y equals -3. When I'm solving these, I only care about my x value, so my answer here is 4. Then, moving on to number 6, it says for the recursive definition, what is the explicit definition? So, what I want to do is, this 6 is my d, so I am going to plug into the formula a sub n equals, let me write out the formula first. So this is the explicit formula. A sub n equals a sub 1 plus d times n minus 1. I'm going to fill in what I know. So I have a sub n equals 11 plus 6 times n minus 1. And then I just want to simplify. So that's going to be 11 plus 6n minus 6. And then I want to combine like terms. Oops, 11 minus 6 is not 11. I'm going to write the 6n first, and then plus 5 for my explicit definition. Number 7 wants me to find the sum of the infinite series. I need to first figure out how many terms there are. Because there are 3 dots here, that means I don't know how many are in the middle. So what I'm going to do is I'm going to use this basic formula again. I know my last term is 46. I know my first term is 4. If I take a look, each of these numbers are counting by 3, so that's my common difference. Then I just want to go ahead and solve, so I'm going to subtract 4 on both sides. I get 42 equals 3n minus 1. I can choose to distribute the 3. I personally am going to divide it on both sides. So 42 divided by 3 is 14. So I have 14 equals n minus 1. I add 1 to both sides. I get 15 equals n. Now that I know my total number of terms, I'm going to use s sub n equals, oops, this is an n times a sub 1 plus a sub n divided by 2. So I know all of these things. A sub 1 is my first term, a sub n is my last term, n is my number of terms. So I have s sub 15 equals 15 times my first term 4 plus 46 divided by 2. So I'm going to type that in. 4 plus 46 is 50 divided by 2, which gets me 375. Okay. Number 8 says there's 2 parking garages in Phoenix. Central Parking charges a flat fee of $10 and $2 per hour for every hour they're parked in the garage. Washington Parking charges a flat fee of $4 and $4 per hour for every hour they are parked in the garage. Write a system of linear equations to find the number of hours for which the costs are the same. So I am going to write my system. Central Parking is going to be y equals a flat fee of 10 plus $2 per hour is 2x. Then Washington Parking is going to be y equals 4 plus 4x. So it wants me to find the number of hours for which the costs are the same. I want to go ahead and solve. Because I have them both equaling y, I'm going to use the substitution method here. So I'm going to have 10 plus 2x equals 4 plus 4x. So I'm going to start off by solving for my x. I am going to subtract 2x on both sides. I have 10 equals 4 plus 2x. Then I want to subtract 4 on both sides. I get 6 equals 2x. Divide both sides by 2. X equals 3. Then I want to go ahead and plug into one of my equations. I'm just going to pick the top one because 2 is a smaller number. So I have y equals 10 plus 2 times 3. That is 10 plus 6, which gets me 16. So I just wanted to find the number of hours that were the same. This is going to be 3. I didn't need to plug in the y. Okay. I could tell I didn't need to plug in that y, and I should have read the problem because it said number of hours and I was using x to represent hours. So, number 9 says in June I start a holiday savings account with a deposit of $30. I increase each monthly deposit by 4 until the end of the year. How much money will you have saved by the end of December? So what's happening here is I have 30 in June. Then in July, I have 34. In August, I have 38. In September, I have 42. October, I have 46. November, I have 50. And December, I have 54. So I am adding all of these together. I can either use my series formula, or I can go ahead and add all 7 numbers together. I am going to use my summation. So I'm adding 7. There's 7 numbers. I'm going to do 30 plus 54 divided by 2. So 7 parentheses 84 on the top divided by 2 gives me $294 total dollars at the end. Number 10 wants me to fill in the missing terms. This is subtracting by 3. So I want to add 3 to go the other way. This is going to be -10, -7. Number 11 wants me to solve the system algebraically. Here I can either use substitution or elimination. Because I use substitution in number 8, I am going to use elimination here. So I'm going to take this and multiply by 4. That's going to give me -4x plus 4y equals 16. And then I'm going to rewrite my top equation. Then I want to add down. My x's cancel out. I have 7y equals 0. I'm going to go ahead and divide both sides by 7. Y equals 0. I'm going to plug into whichever equation I want. I'm going to pick the bottom one because there's no coefficients on y. So I have -x plus 0 equals 4. -x equals 4. I want to go ahead and divide both sides by -1. And I get x equals -4. So my answer here is -4, 0. Because you always write your answers in the form x, y, alphabetical. Okay, number 12 just wants me to write a matrix for the system of equations. I am going to take my coefficients and then write them out. So I have a 4, -1, 2, and then 10. On the second row I have a 5, a 2, a -3, and a 0. Last row, remember anything without a number in front is assumed to be 1. So I have 1, -3, 1, and 6. When I write my matrix for a system of equations, I want to make sure my letters are always in alphabetical order. And I want to represent any missing letters with a 0.